Well, how are we going to handle this thing? Remember, it's like a binomial. When we square a binomial, we don't just distribute the squared. We have to write it out and FOIL it out, right? So we're going to write it out and FOIL it out. We'll have 5 minus 2i times 5 minus 2i. And that's going to get us 25 minus 10i plus 4i squared. But we remember that I squared is equal to -1, so that's 4 times -1, or -4. 25 minus 4 is 21 minus 20i. So in good a plus bi form, we end up with 21 minus 20i. Is this super easy? It should be a review, but we are going to use complex numbers throughout the year, so we need to make sure that we look at them and that they show up on the CLEP test. Okay? So here's an example of one that shows up on the CLEP test. All right? So what do we got this time? We've got, if I took this thing to the 5th power, could I make that the cube root of 3 to the 5th power and I to the 5th power? Because that's like a monomial, right? There's no addition or subtraction sign in it. It's just the imaginary number, square root of 3i. And I do want to point out, notice that I is not under the radical. See how I wish they would write the I in front of the radical, which is how I'll write them in here to make sure that you know that the I is not under the radical. But you can see, because that's typed out, that it's very specific, it's not under the radical, right? So we just have to raise everything to the 5th power. So could I think of that as the square root of 3 times 3 times 3 times 3 times 3? And I could bring out 2 3s and get 9 square roots of 3 from that part. Now, here I'm going to get I to the 5th power. I told you earlier that if you had the square root of -1, it was I to the 1st power. I to the 2nd power was -1. I to the 3rd power was -I. I to the 4th power was +1. And I to the 0 power was +1. I didn't tell you how to do I to the 5th power. Could I write that, though, as I to the 4th power times I to the 1st power? I is not a variable, okay? But we treat it a lot like a variable. So if I wanted to break that down, I could break down I to the 5th power into I to the 4th times I to the 1st. But what is I to the 4th power? So could I write that as 9i square roots of 3? Or they write it as 9 square roots of 3i, which is answer B. All right, y'all with me? All right, so let me show you something that will help you too. I just showed you one way to deal with I to the 5th power. But let's say I had something like I to the 137th power. We would not want to write out I to the 4th times I to the 4th times I to the 4th all the number of times that it would take us to get to I to the 137th power. So here's a shortcut for doing that, okay? We're going to take the power, 137, and we're going to divide by 4. Why 4? Because I to the 4th power is 1. So every single time that 4 goes into 137, it would end up being an I to the 4th power, which is 1. So if I divide that, I'm going to get, that's going to be a 3, which is going to be a 12. When I subtract, I get 1. Bring down my 7, that would be a 4. So that would be 16. Subtract and get 1. So I to the 137th power is equal to I to the 1st power, whatever the remainder is. And we know I to the 1st power is just I. So there's a little shortcut. Anytime that we have I raised to a power higher than 4, we just take that power and divide by 4 and look at the remainder. So let's try another one here. If I had I to the 69th power, how am I going to determine what that equals? Well, I'm going to take the 69 and divide by 4. And then I'm going to take 4 into that and get 7. And so I to the 69th is the same thing as I to the 1st power, whatever the remainder is. And that gets me that it's just I. Y'all with me? So the little shortcut is so you don't have to go I to the fourth times I to the fourth times I to the fourth times I to the fourth. You just divide by 4 and whatever the remainder is. And remember, the remainder can only be a 0, a 1, a 2, or a 3. Because if it's anything bigger than a 3, then 4 would have gone into it another time, right? Y'all with me? All right. So here's another question, and they want to know which of these numbers are real. So before we can decide, we're going to simplify them and see if they're real, right? Look at this first one. What does I squared equal? So that's really negative 1 over 5. Is that a real number? Yeah, it's a rational number, and rational numbers are real, so it's okay. It would be in our answer. If we wanted to simplify this one, let's see. That's negative 4. What does I squared equal again? So that's really negative 4 times negative 1, which would be the square root of 4. And the square root of 4 is 2. That's a real number. What about the third one? Negative 16i. Can I simplify that any? Is it real? How do I know it's not real? Has an I left in it. Can't get rid of the I, right? So our answer is D, only Roman numeral 1 and Roman numeral 2. Y'all with me? Not bad? So these show up a lot, okay? Notice I've already done several, and we've got some more here. We're just foiling those out and simplifying. Here how are we gonna do that? Write it out 3 times and multiply. Multiply 2 of them and then simplify that and then multiply by the third one, right? Okay. Well, how do we divide by a complex number? Remember back when we were dealing with radicals, we said we could not have a radical in the denominator. And what does I equal? Square root of negative 1, right? So we can't have an I in the denominator. Can anyone think of some technique that we used the last time to solve this? Good. When you say opposite of it, what do you mean? Someone said the right term over there, but what do you mean? Someone said it? The conjugate. Okay, it's called the complex conjugate. Complex conjugate. And so we could multiply. What is the complex conjugate of 4 plus I? 4 minus I. See, sometimes you guys know what to do, but you don't know the right terminology. And the reason that I bring that terminology out is, remember, on the ACT test and on the CLEP test, they're going to use correct mathematical terminology. And if you aren't used to hearing that, you might read it and it confuse you. And I don't want it to confuse you, okay? So here we're going to distribute, and we're going to get 12 minus 3i. And here we're going to get 16 minus 4i plus 4i, and then minus I squared. Is everyone with me on the FOIL? Now, why did we multiply by the complex conjugate? Well, that's always going to make those two things in the denominator cancel. And what did we say I squared equaled? So that's really negative 1 or positive 1. So the answer would be 12 minus 3i over 16 plus 1, or 17. And that's a perfectly fine way of writing the answer. Can anyone think of another way we could write that answer and it still be correct? You might see it written like this: 12 over 17 minus 3 over 17i. Either one of these answers is a perfectly fine answer. And the reason that I bring out both ways that they do it is because I can't control how they're going to do it on the CLEP test, okay? And so if you're only used to seeing it like this, and then they put it in the other form, you might be confused. I don't want you to be confused. I want you to see that both of those are correct. All we did was take the numerator real number and divide by the denominator real number, and then the coefficient for our I and put it over our denominator, okay? Either one of those answers are correct, and they won't have both choices on the test. They'll have one or the other. But you need to be familiar with, if you're only used to seeing it in this form, and then that shows up on the test in the other form, you might be confused. I don't want you to be confused. I'll always try to bring that kind of stuff out to you, okay? Well, then what are we going to do here? How am I going to simplify this rational expression? Good. She says that we could multiply both the numerator and denominator through by 4 minus 3i, called the complex conjugate. And why am I allowed to do that? 4 minus 3i divided by 4 minus 3i is just what? What's anything divided by itself? 1. And I can multiply anything in mathematics by 1 without changing its equality, right? I might change its form, but not its equality. So I'm going to have to FOIL the numerator, which is going to get me 12 minus 9i minus 16i plus 12i squared over, and I do the denominator, I get 16 minus 12i plus 12i minus 9i squared. Is everyone with me on the FOIL? Well, we know that these two things are going to cancel. Anything else we can simplify? The I squareds. And so if we do that, that's going to be 12 times negative 1 or negative 12. And this is negative 9 times negative 1 or positive 9. So when we start to simplify, that's going to get us 12 minus 12 would be 0. Negative 9i and negative 16i would be negative 25i. Those two cancel, and we have 16 plus 9 is 25. If we broke that up, could we write that as 0 over 25 minus 25 over 25i, which would be 0 minus I, or could we just say negative I? Y'all with me? If they wanted it in good complex number form, a plus bi form, we could leave it like that. But in simplest form, it might just come up like that. Go with me? Again, I'll try to point out anything that could happen because I don't want you to get surprised or confused when you're on the CLEP test. Okay? So here's an example on the CLEP test of that exact same thing. We would have to multiply both the numerator and denominator through by the conjugate, and then it says all they're wanting here is they just want the value of a. They just want the real number part. Okay? The real number part once we get our answer, not the whole thing. Remember how I told you on the CLEP test, whenever they gave you a free response question like that, it was going to be a number. So they wouldn't put the whole complex number. It wouldn't be 5 plus 2i. They wouldn't put that on there. They'd only ask for either a or b if they were going to have a complex number. Does that make sense? All right. Same thing. We're going to simplify. They're going to give us, they just want a. Just A, okay? They might say just B. They could do that just as easily. Here, same, oh, they did. Here's one where they just want the B. They want the coefficient for the imaginary number. Here, this is really dividing because we notice that we would substitute in this for A, and we'd substitute that this in for X, and we'd substitute this in for Y, and then we'd be back to having a complex number divided by a complex number, and we would simplify that. So they can ask these questions in a lot of different ways, and we just need to be familiar with all the different ways